Hello everyone, myself Dr. Santyavi Kundu. I welcome you all to this lecture of soft computing technique. This is the second lecture of module 5. So, in module 5, we have discussed basic definition of selection operator, population diversity and selection pressures, exploration and exploitations. This lecture will try to understand some techniques of selection operators. So, in genetic algorithm, selection methods are used to choose individual from the current population to create offspring for the next generation. Different methods have different mechanism for selecting individual based on their fitness, which affects the speed of convergence and the diversity of the populations. First one is that tournament selections. Tournament selection is a popular selection method used in genetic algorithms. In this method, individuals are selected based on a competition among a randomly chosen subset of the populations. The winner of the competitions are selected for reproduction. This method is commonly used because it is relatively simple to implement and has good performance in terms of maintaining diversity and avoiding premature convergence. How tournament selection works? A fixed number of individuals, called the tournament size, typically two or more, are randomly selected from the populations. Compare fitness, the fitness of the individuals in the tournament is compared. The individual with the best fitness, highest or lowest depending on the problem, is selected as the winner. Repeat this process until the required number of individuals are selected to form the mating pool for the next generations. Key points: tournament size. The number of individuals selected for each tournament can vary. A tournament size of 2 is the most common, where 2 individuals are selected and the one with the better fitness wins. Larger tournament sizes can increase selection pressure. Selection pressures. Larger tournaments, larger tournaments lead to higher selection pressures as individuals with better fitness have an even greater chance of being selected. Smaller tournaments lead to lower selection pressure and promoting greater diversity. Advantage of tournament selections. First one is simplicity. Tournament selections is easy to implement and does not require sorting or complex calculation like roulette wheel or rank selections. Selection pressure control. The tournament size can be adjusted to control the selection pressures. Larger tournaments result in a higher chance of selecting individuals with better fitness, while smaller tournaments preserve diversity by giving less fit individuals a chance. Efficient. Unlike roulette wheel, which may require normalization of fitness values, tournament selections only require comparison between individuals, making it computationally efficient. Resistance to premature convergence. The randomness of tournament selections can help maintain diversity in the population, reducing the risk of premature convergence. Disadvantage of tournament selections. Unlike fitness proportional selection methods like roulette wheel, tournament selection does not guarantee that the probability of selection is proportional to the fitness. A slightly better individual can win even it is even its fitness is only marginally better than others in the tournament. Potential for favoritism. If the tournament size is too large, the selection process may overly favor the fittest individuals and ignore others, leading to reduced diversity in the population. So there is a now example of a tournament selection. So in the tournament selections, several tournaments are played among a few individuals. The individuals are chosen at random from the populations. The winner of each tournament is selected for next generation. Selection pressure can be adjusted by changing the tournament size. Weak individuals have a smaller chance to be selected if the tournament size is large. So their fitness value, first one is 22, second suppose it's maximize problem. So first one is 22, then 13, so greater value 22, so this is selected. Similarly for 28 and 38, 38 is selected, 40 and 28, 40 is selected, 20 to 25, so 25, then 28 to 32, 32 is selected, then 45 to 13, 45 is selected. So the sample, so the chromosome which fitness is 22 is selected similarly for others. Another example is that suppose individual 1, 2, 3, 4, 5, 6, 7, 8. So the 8 individuals, the fitness are for 1, 1.0, for 2, 2.1, for 3, 3.1, for 4, 4.0, for 5, 4.6, for 6, 1.9, for 7, 1.8, and for 8, 4.5. Now there are trial 1, 2, 3, 4. So individuals are 2 and 4. So 2 and 4, the comparison between 2.1 and 4.0, so 4.0 is maximum, so 4 is selected. 3 and 8, 3 is 3.1, 8 is 4.5, to 8 is selected. 1 and 3, 1 is 1.0, 3 and 3.1, so 3 is selected. 4 and 5, 4.0, 4.6, 4.6, so 5 is selected. Similarly for the trial or tournament number 5, 6, 7, 8. So 5 played between 1 and 6. So 1, 1.0, 6, 1.9. So 6 is selected. 1 and 2, 1.0, 2.1. So 2 is selected. 4 and 2, 4.0 for 4, 2, 2.1. So 4 is selected. 8 and 3, 3 is 3.1, 8, 4.5. So 8 is selected. So this is the concept for the tournament selections. Now another important selection technique is roulette wheel selections. So roulette wheel selection is a fitness proportional selection method, meaning that the probability of selecting an individual is directly proportional to its fitness. Now how it works? Each individual in the population is assigned a segment of the roulette wheel based on its fitness. The size of each segment is proportional to the individual fitness relative to the total fitness of the population. A random number between 0 and 1 is generated and the wheel is spun to select an individual. And wheel is spun to select an individual. The individual corresponding to the position on the wheel where the random number first is selected for reproductions. Advantage is that simple and easy to implement. It allows better individuals to have higher chance of being selected. Disadvantage can suffer from premature convergence if a few individuals dominate in the population, as their fitness dominates the selection pressure. The method can be inefficient if there is a large disparity between fitness values, resulting in very small probabilities for some individuals. We'll discuss through numerical examples. So there is a roulette wheel method, so proportional selections. So parents are selected according to their fitness values. The better chromosome have more chances to select it. So with the chromosome number 1, 2, 3, 4, 5, 6. So for 1 fitness value is 50, for 2 fitness value is 6, for 3 fitness value is 36, for 4 fitness value is 30, for 5 fitness value is 36, for 6 fitness value is 28. So if you all these fitness, this will give you the 186, the total of all this. Now 186, so suppose this roulette wheel, this is the 100%. So roulette wheel, suppose the roulette wheel area, this area is 100%. So you can say that 186 is equivalent to 100. So 186 is equivalent to 100. So 1 is equivalent to 100 by 186. So 50 is equivalent to 150. 50 is equivalent to 100 by 186 into 50. If you calculate these things, you will get it 26.8817. So we are writing it 26.88. So this the percentage of the royalty field is 26.88. Similarly, if you write 100 by 186 into 6, you will get 3.47. For 36, 20.81. For 30, 70.34. For 36, 20.81. For 28, 16.1. So this is the percentage of the wheel, 100%. So this 26%, 26.88 belongs to one chromosome. Then for 3.47 is belongs to chromosome 2, 21.81 belongs to chromosome 3, then 4, then 5, 6. So now we are working on the 6 chromosome. So you need to select 6 elements. So you can say that now 100 is equal to 6. So 1 is, if 100 is equivalent to 6, so 1 is equivalent to 6 by 100. So 26.88 is equal to 6 by 100 into 26.88. So that will get 1.6128. So I'm writing it 1.61. So that is known as the expected count, because total 6 chromosomes there. So here 100 is equivalent to 6. So 26.8 is equivalent to 1.61. So that is the expected count. Similarly, this is 0.19. So that is also expected count equivalent to 0. So here that for 3.47 you can write it that, and 6 into 3.47 divided by 100, so you will get it 0.19. Similarly, for expected count is 1.16. Here is also 0.97, 1.16 for the fifth one, for sixth one 0.90. So if we add, you will get 6 here. So now expected count 1.61 is 2. So that means the chromosome 1 is selected 2 times because its fitness value is higher. Similarly, for 0.18 equivalent to 0, 1.16 can equivalent to 1. So that is the actual count. This also can equivalent to 1. This also can equivalent to 1. This also can equivalent to 1. So the next iterations, we will select chromosome 1 for 2 times. Chromosome 2 is not selected. Chromosome 3 selected 1, 4, 1, 5, 1, 6, 1. So these 6 chromosomes are selected. We'll solve some example on the based on the random numbers. So this is one technique of roulette wheel. So now problem with the roulette wheel selection schemes. The limitation in the roulette wheel selection scheme can be better illustrated with the following figure. Suppose there is chromosome 1, 2, 3, 4. For 1, the fitness is 0.4. For 2, fitness is 0.05. For 3, 0.03. For 4, 0.2. So if you say the roulette wheel portions, so here you will write that the total is 0.5. So 0.5 means the 100%. So 1 means 100 by 0.5. So 0.4 means 100 by 0.5 into 0.4, that is 80. So 80% is belongs to the chromosome 1 because its fitness is higher. Similarly, for 2 you will get only 10%. For 3 for 3 that is 0.03 you will get 6%. For 4 that is 0.02 you will get 4%. So 80% belongs to the chromosome 1 as it is the better fitness value. So the observation is that the individual with higher fitness values will guard other to be selected as a parent. This leads to lesser diversity and hence fewer scope towards exploring and hence fewer scope towards exploring the alternative solutions. Can also premature convergence or early convergence with the local optimum solution. To overcome the problem with roulette wheel selections, a rank-based selection scheme has been proposed. The process of ranking selection consists of 2 steps. One is that individuals are arranged in an ascending order of their fitness values. The individual which has the lower value of fitness is assigned rank 1 and other are ranked accordingly. So the proportional based selection scheme is is then followed based on the assigned rank. So we need to have a look on rank selection method. So first to check on rank selection method. The rank selection avoid the issues of fitness proportional selection such as premature convergence and large difference in fitness as you seen earlier. So by ranking individual according to their fitness and selecting based on the rank rather than the absolute fitness values. How it works? So all individuals in the populations are sorted based on their fitness. Each individual is assigned a rank starting from 1 for the fittest individual. The probability of selection is determined based on the rank, not the raw fitness value. For example, the highest ranked individual could have selection probability of 1 and the second has 0.9 and so on. This method reduces the impact of extreme fitness values. Advantage is that eliminate the issue of large fitness difference causing one or a few individuals to dominate the selection process. The selection pressure can be controlled by adjusting how ranks are translated into the selection probabilities. Disadvantage can still lead to premature convergence if the ranks of many individuals are similar. This method still involves sorting the population, which can be computationally expensive. So try to understand this method. So the percentage first will find the individual, suppose 1, 2, 3, 4. So with the same fitness 0 0.4, 0 0.5, 0 0.3, that 0 0.2. So the lowest value put it rank 1, second rank 2, third rank 3, 4, that is rank 4. And this is the roulette wheel, the percentage area I calculated earlier. So now here total is what? Total is this is 10. So here 100% or 10 is equivalent to 100%. So here 1 is equivalent to 100 by 10. So 4 rank is equivalent to 100 by 10 into 4 into 4, so that is 40%. So earlier it was 80%, now rank selection method will get the area 40%. Similarly for rank 3, so here 10 means 10 is equivalent to 100%, so 1 is equivalent to 100 by 10, so 3 is equivalent to 100 by 10 into 3, that is 30%. So that is for chromosome 2, so this is for chromosome 1, this is for chromosome 2, this is for chromosome 3, this is for chromosome 4. So here you can see the percentage area occupied by particular individuals is I is given by Ri, summation of Ri into 100. I will check here. Here Ri indicates the rank of the ith individual. Two or more individuals with the same fitness value should have the same rank. Continuing with the proportions of 4 individuals fitness, F1 is 0.4, F2 0.05, F3 0.03, F4 is 0.02, so it gets this area. So that is the example of the rank selection method. So similarly, for that earlier question what we have done here, so chromosomes are here 1, 2, 3, 4, 5, 6, fitness we know that is 56, 36, 30, 36, 28. So rank the lowest 1, then 2, then 3, then 4. Both are the 4 rank, then 5. So if this you also get this type of results. So this is the concept of rank selection method. So now the steady state selections. So in this method, a few good chromosomes are used for creating new offspring in every iterations. Then some bad chromosomes are removed and the new offspring is placed in their places. The rest of the population migrates to the next generation without going through the selection process. So suppose this is the initial stage, some good, some bad. So good automatically go to the new offspring. So now here we can create crossover to get the another samples. So this is known as the steady state selection method. We'll solve it by some numerical examples. So now to try to understand one question. Question is that there are few chromosomes 1, 2, 3, 4. For 1 fitness value is 109. For 2 fitness is 76. For 3 fitness is 50. For 4 fitness is 153. Find the expected count, so that is EC. Find expected count and actual count by roulette wheel selection and pair selection methods. So try to solve this question. So let I'm giving you some hint. Hint is that, so here chromosomes are 1, 2, 3, 4. So for O1 this is 109, for 2 76, for 350, for 4 153. So here you can say that the rank of 3 is 1, this is 2, this is 3, this is 4. So total rank is, you can say, 10. So area in roulette wheel will have you that here the value 10, because equivalent to 100. So 1 is equivalent to 100 by 10, 3 is equivalent to 100 by 10 into 3, so that is 30. So it will get 30% in the roulette wheel, it will get the 20% in roulette wheel, it will get 10% in roulette wheel, it will get the 40% in the. So now how the steady state works. So in each generation, a few individuals are selected to reproduce and replace a few of the least fit individuals in the current populations. The process often involves selecting parents, producing offspring, and then replacing the host individual in the population with the offspring. The population size remains constant. So that is the steady state selection method. So advantage is that it preserves population diversity better than methods like generational selections, which might lead to uniformity in the populations. Since only a few individuals are replaced at a time, the population evolves more slowly and steadily. Avoid large-scale disruption in the populations. Disadvantage: it may slow down convergence because only a few individuals are replaced and computationally expensive if selecting and. So in conclusions, selection, steady state selection, etc. So in this class we have discussed selection technique. So question for today's class is that, with a proper example, try to solve a questions by tournament selection and rank selection. So these are the references for today's class. Thank you.